Let's get this whole volleyball thing. Got that so you have a
All right, year 11's quieting down. We're going to start.
This is so big. Because I'm prepared. Why do you think I carry so many notebooks around? Why carry what?
I'm waiting. Thank you. Okay, would you like to review what we did last week first? I'll do a quick review. How about that? So before, yeah, I think it's recording. If it's not recording, it's not the end of the world. So before we get into matrix multiplication, I'm going to give you two matrices. They look like this. Alright, so I've given you two matrices. I want you to calculate the following for me. I want you to calculate A plus B. The second thing I want you to calculate is, let's say, 3A. Right, so just take a couple of minutes to do that. All right, how are we going? Who's finished? No? Okay.
It's 3. Plus 2. It's 3. The first one. Divided by the first one. Are you good at this? What other things?
Yeah. Whoops.
Are you right?
Now we'll fix it. 2.
We could have just changed A to B.
I could, but it's too late. All right, apologies for that. Can you all see that okay?
Yeah.
Okay, so you don't have to write what's in the middle. The middle is to show you what's happening if you want to understand the definition lying behind matrix addition and matrix scalar multiplication. So how would you put into words what's happening here? Let's start with addition. If I want to add two matrices, how would you describe in words what we do here?
You add the numbers that are in the same spot.
Exactly. Take the numbers which are in the same position and add them together. That's it. All right, what about scalar multiplication?
You multiply by
Great. keep all the numbers in the same position and just multiply them by the number on the outside.
Sir.
Okay, great. You ready for something new?
Yeah.
No.
Yes.
You are now. Okay. All right. I'm going to start with an example, and then I will explain how to do it. So, basically, the way I'll say this is, it's harder to explain it than it is to do it. So what I'm going to do is I'm just going to do it first, and then you might be able to see what I've done, and then I'll try to explain it to you. Okay. All right. So let's say I have two matrices that look like this. Okay, so notice I've got a matrix in front of the matrix, not a single number now. So you might think, oh, just multiply the numbers in the same position together, but it's not that. Looks like this.
No. I disagree.
Okay, the rest is just arithmetic at this point, but I will do it. Okay, so this might come as a surprise. You might have thought, oh, 1 times 5 will give me 5, and 2 times 6 will give me 12.
2 times 7.
Okay, so let me try to explain why this is happening. We could have defined it that way. Matrices have been around for a long time, I would say hundreds of years, and the people who constructed matrices found this to be a very useful thing to do with matrices. So when we come to solving simultaneous equations in about a week's time, using this definition of matrix multiplication will be better for us. Okay. The paper is about to get very messy, but I hope that this will be helpful. So how do we get the first row, first column? This is what you do. You take the first row in the matrix on the left, and you take the first column in the second matrix. So you see 1 times 5, 2 times 7. 1 times 5, 2 times 7. Now I'm going to...
Why?
Alright, I'm going to pick a different color now. Let's say I wanted a number in the second row, second column. I take the second row in the first matrix and the second column in the second matrix. Alright, 3 times 6, 4 times 8.
They're gonna be doing that a lot.
They'll be going for the whole day.
Why don't they just do it like after school?
Alright. So, just by showing that, I think it's almost enough to be able to do it on your own.
But what about the other two?
Hmm?
What about the other two?
Same idea. So let's say you wanted to find row 1, column 2. You would use row 1 in the first matrix and column 2 in the second matrix. So I'll need to write it out again, because at this point it will become too messy. So Kaylin's asked a good question. What about the numbers that I didn't circle? Okay. So let's say I wanted the number in row 1, column 2. I would use row 1 in the first matrix and column 2 in the second matrix.
So the other one we use row 1.
Right? So basically, if you want row I, column J in your answer, use row I in the first matrix and column J in the second matrix. Alright, so see here, Kaylin, the first column is in red,
Yeah.
whereas here, the second column is in red, because now I'm looking at the second column of the answer now.
Yeah.
Okay? Similarly, if I wanted this number, which is in the second row, first column, I would take the second row in the first matrix and the first column in the second matrix.
Can you write that out as a purple?
Write that.
Could you write that out as a purple?
Yes. So I wanted to show the picture first. Alright, so now at Jazz's request, I'll put this into words now. So, to get row I, column J, when multiplying two matrices, use row I in the first matrix and column J in the second matrix. Hopefully you're seeing why I didn't start with this. But I tried to show you the picture first. Okay. I think what we need is more examples so that we feel a bit more comfortable doing this.
Thank you.
Okay. Okay, I need to write something else as well. So, suppose we want to calculate the matrix product AB, so the two capital letters A and B next to each other. If A is M by P and B is P by N, sorry about all the letters, then AB is M times N. Here I'm referring to the order of the matrix. If the number of columns in A, so I've allocated a whole double period for this. We're not going to do anything else than matrix multiplication today. Yep. Okay. If you're copying this down, that's fine. But follow along with me here. What's the order of this matrix here? 1 times 3. So remember, it's rows times columns. So there's 1 row and 3 columns. What about this matrix? What's the order of this one? 3 times 1? Okay. So when I write two matrices next to each other and I want to multiply them, the first thing I need to check is whether these two numbers on the inside, that is the number of columns in the first matrix and the number of rows in the second matrix, I need to check that those numbers are the same. If they're not the same, I can't multiply the matrices together. Okay? I test this on the assignment, so you need to know that. So, can I multiply these two matrices?
Yes.
Yeah, because the numbers on the inside are the same. Okay, the next thing is, we need to decide how big the answer is going to be. So here I've said, if it's m by p, the first matrix, and p by n, the second matrix, then your answer is going to be m times n. Now I know there's a lot of letters there, but just think about it as the outside numbers. So if the inside numbers are the same, you can multiply the two matrices, and your answer is going to be, in this case, a 1 by 1 matrix. The matrix is only going to have one number. Is that okay? You check whether you can multiply the two matrices by looking at the inside numbers, and then use the outside numbers to determine the order of your answer. Okay? I reckon that's easier than doing that, but they're the same thing. Okay. So, let's apply this definition now. To get row 1, column 1 in my answer, use row 1 in the first matrix and column 1 in the second matrix. So it's literally just going to be 1 times 1 plus 2 times 2 plus 3 times 3. 1 plus 4 plus 9. 14. Okay, who's lost? So it is in the textbook, and you will always be allowed to use a calculator in an assessment, except for the first 2 questions on the assignment. Simply do that by hand. So in questions 1 and 2 of your assignment, I ask you to do it by hand. Okay? Just this once, so that you understand what's going on. Alright, let's look at the second example now. So this time the matrices have just been swapped around. What's the order of my answer going to be this time?
No, incorrect. It's going to be 3.
3 times 3. Why? We use the outside numbers. Okay? So notice something very interesting. If I swap the order of two matrices, I might get a different answer. Right? This one was a 1 by 1 matrix. Now we're getting a 3 by 3 matrix. So they're different.
I understand.
Okay?
No, I've lost it. Keep going.
I'll keep going.
I'll understand.
So you understand why I allocate the whole double for this, yeah?
So the outside numbers determine the size
the size of your answer. That's right. Okay? All right. So there are going to be 9 numbers in this matrix. To get row 1, column 1, use row 1 in the first matrix, column 1 in the second matrix. So it's going to be 1 times 1, which is this 1. First row, second column, 1 times 2. 1 times 3. 2 times 1. 2 times 2. 2 times 3. 3 times 1. 3 times 2. 3 times 3. Sorry that it's a bit small.
Hey, size doesn't matter, Mr. Chu.
Hmm?
Size doesn't matter.
Okay. All right. All right. Have a look at the third example now. What's the order of my answer going to be? 2 times 1, we're using the outside numbers. Okay? So if you don't know what to do, start by writing down the order of the matrices that you are multiplying. I know that my answer is going to have 2 rows, 1 column. All right, this time I can color code it. So to get the first number, I need to use row 1 in the first matrix, and well, there's only 1 column in the second matrix. It's going to be 1 times 5 plus 2 times 6. And that didn't work out as well as I would have liked. Jason? Tom? Alright, if I want the second row, I will use the second row in the first matrix. Row 2, column 1. Okay, I'm going to take a poll of the room. Thumbs up if you think you're ready to go and start some questions. Middle if you think, give me another example or two. And thumbs down if you're like, Mr. Chu, you're on a different planet. Come back. So where are you? Okay. I will do one more example. If you want to get started, feel free to get started. Yes? Hmm? Yeah. Okay, so this last example is for you. Yeah, sure. So what do you need, Claire? Yes. Can I turn the page, Claire? Yeah. Copy off someone else, Cam, because you left the room for like. Okay. Okay, year 11, if I could get you to be quiet if you're working. So this is the last example that I'll go through today. All right. What's the order of these matrices?
2 times 3 and 3
Yeah. Yeah, so remember, it's rows times... Yeah, so you're right, Kai. The answer will have 2 rows and 2 columns. Because these two numbers are the same, so that means I can multiply them together. All right. To get row 1, column 1, so guys listening, let's say I want just the first number in row 1, column 1. What should I use to get the answer? Which parts of the 2 matrices?
row 1 and then column 2 on the other one.
So row 1 in the first matrix,
On and
but you want to use the same column number. So this is in column 1 in the answer. So you're going to use column 1 in the second matrix. Okay? So I actually need to make this bigger. Make sense? Okay, let's say I wanted, hang on. Let's say I wanted row 1, column 2. I will still use row 1 in the first matrix, but this time I will use column 2 in the second matrix. Then I take these pairs of numbers, multiply them together, and then add them up. Alright, if I want to find row 2 now in the answer, this time I will use the second row of the first matrix. So 4 times 7 plus 5 times 8 plus 6 times 9. So notice that I'm still using the first column in the second matrix, but now I'm using 4, 5, and 6. Instead of 1, 2, and 3. Okay, so I'm going to leave it there. I want you to practice doing this by hand first. In a moment, I will show you how to do this on your calculator. Okay? But you can get started. All right, thank you.